everyone, and welcome back. In the previous video in this 4100 series, we looked at completing a basic vibration survey and how we can take that vibration survey information, review it after the fact, and determine if an engine can or cannot be balanced. We determined in the case of our roto rig, which we use for demonstrations, we have a pretty good shot at completing a basic vibration balance. In this video, we're going to use that acquired data to complete a trial weight balance for the engine. We're already here in the main tab of our WinPBS software. To enter the balance wizard, we'll just click Balance Engine here or click F3. This will open the balance wizard. In this case, we want to start a new trial weight balance for our RotoKit engine with engine ID of test. On the second page, it'll introduce to us the steps of completing a trial weight balance. At the bottom, we'll put a name for this trial weight balance. In this case, I'll just put RotoKit trial weight balance, and I'll put today's date, just for reference. The system's now going to ask us if we have any vibration runs that we would like to use. In this case, we do. We just completed a vibration survey for the acceleration on 3/31/2021. When we click Next, the system will automatically pick out the speeds of interest for us. In this case, we're interested in balancing at 2,000, 4,000, 6,000, and 8,000 RPM. The system has automatically selected these and demonstrated them with a little red dot at each speed of interest. The system will then tell us that if we wish to proceed, we can back up no further, and that if we continue to proceed, we must finish the balance. We'll click Next here, recognizing that there's no backing up from this point. If we did need to back up, we would just have to restart the balance. The system now tells us to define a basic trial weight that we're going to use to install in the system. In this case, I've got a small set of trial weights, and I'm going to install a P08 and hole number 1. If I show the graph, which will pictorially represent my added trial weight, it will show us where to add the trial weight on the engine. I can then add this weight, and then we can do the trial weight run, which is one P1 Class 8 into hole 1. We can now proceed to the next step of the balance. It will now ask us for the vibration analysis run with the trial weight installed. However, in this case, we haven't done it yet. With the new WinPBS software, we can actually complete a new survey inside of the balance wizard by clicking here. This will automatically pull up the Acquired Data tab, which we can use to acquire data. The engine's now currently running about 250 RPM, and we're ready to acquire data with the trial weight installed. To do this, we'll simply start the survey, note it as an acceleration, as a trial weight, and then I'll put the date. And I'll click Begin Survey, which will clear out any existing data and start taking new data with the engine accelerating. The engine's now accelerating, and the DAU is collecting information with the trial weight. When doing a trial weight run, vibrations may be larger than equal to or less than the original vibration. The system will look not for higher or lower, but for a difference in vibration. In this case, the vibrations are actually a little bit higher with the trial weight installed, but still well below our 1.2 self-imposed limitation. Again, we're looking for a good relationship between the broadband and the N1 curve, which we're seeing. And as we approach 9,000 RPM, we're ready to start the deceleration. We can now stop the survey and decelerate the engine. We won't start another survey since we're not going to collect the deceleration data, but we will monitor it to make sure that the engine behaves similarly in deceleration as it did in acceleration. And just as we hope, we see that vibration spike around 3,800 to 4,000 RPM with a rapid fall off around 3,250. Now that we've seen the deceleration, we can go down to the bottom and return to our balance. Now we can see that our new acceleration trial weight balance can be used. Click Next, and again, just like the initial vibration analysis run, the system will automatically pick out the vibration levels at each speed of interest, 2,000, 4,000, 6,000, and 8,000 RPM. We then click Next, and then it tells us to return to the baseline configuration, and this is important. Always remove the trial weight before proceeding. Trial weights with the PBS-4100 system are never part of your solution. If the system deems that the trial weight should be used, it will simply tell you to reinstall it later in the process. All right, my trial weight's removed and I've put it back where it came from so that I don't confuse different weights. We'll click Next. In this case, we have no existing weights in the engine, so we'd put nothing here. If your engine, however, has an existing weight, we'd put it here. The system will now present us with the solution that we're interested in. In this case, we want to put a P1 class 5 at 293 degrees and a P1 class 3 at 315. So the P1 class 5 would be about hole 14 and the P1 class 3 would be in hole 15. If I want more information on this balance, I can click Details, and it will actually provide me with all these information that I would need to determine how the system arrived at a solution. I can print this if I desire. In this case, the system thinks that this balance will be 99.7% effective. So now I'll go ahead and I'll install the weights, a P1 class 5 in hole 14. And a P1 class 3 in 15. Our trial weights are now installed. With the trial weights installed, we can proceed to the next step, which is the check run. The system will ensure that we've installed the proper weights by verifying with us that this is exactly the weights to install, and in some cases the weights to remove, and their locations. It will proceed through a few different ways of presentation, confirm in each step that you've properly installed your weights. The system's now going to ask us for the check run vibration information. However, we haven't done it yet. So just like the trial weight balance, all we do is click New Survey. The system will automatically call the Acquire Data tab, which will let us do a vibration survey. So we'll restart our demonstration rig and get ready to go. The system's now established communications with the DAU, and we're ready to begin. We would expect on this run to have fairly low vibrations, being a check run. So we'll go to the Vibe versus Speed tab. We'll start the survey. We'll name it. We'll begin the survey and begin the acceleration. Immediately we see that the vibrations are significantly lower on this check run than they originally were with this motor. We're going to pay particular attention in that range between 3,000 and 4,000, which is where we saw the original spike in vibration. And in this case, we see that there is no more major spike. So we keep accelerating. We'll continue to monitor to make sure that the vibration levels remain relatively low. As you can see, this is a very, very successful balance. The vibrations are less than 0.2 inches per second, which is very, very good. Once we hit 9,000, we'll stop the survey and begin the deceleration. Again, on the deceleration, we're not saving the data, we're just looking to see if there's any more information that could be applicable in the deceleration that we did not see in the acceleration. Now that the engine is pretty much decelerated with no major differences in the acceleration and deceleration run, we'll just return to the balance. Now we can select our check run acceleration data, click Next, and the system will now show us the result of our balance. It's automatically selected our speeds of interest, and it will now show us how our vibrations were for the baseline or green run and that of the pink or current or check run. You'll notice a substantial decrease in vibrations at that 4,000 RPM mark with a slight increase at the higher RPMs. This is not uncommon when you're balancing at multiple speeds and your vibration levels are fairly low to start with. The system will try to be a jack of all trades but master of none. It will average to ensure that the vibrations at all speeds are relatively good. In this case, we're happy with the balance, so we can complete it. If for some reason the system does not calculate a viable solution for us, or we're just not happy, we can have the system calculate another solution and have it display it, and we can go through the process again. In this case, we'll click Next. And then the system will ask us if we'd like to store the influence coefficients derived from this balance. Since we've had a very, very good balance here, I will update an existing set that we have. In this case, I'll click RotoKit 1 as our influence coefficient set I'd like to update. Click Next. It has successfully updated the influence coefficients, which we'll use in the next video, and the balance is now complete. We can click Finish. It will exit the balance wizard and return us to the main menu. That's it for this video. In the next video, we're going to take a look at doing an influence coefficient balance, which effectively lets us balance the engine without having to do a trial weight run. Until then, we'll see you later.